Hi, welcome back. In this video, we're continuing to talk about solving logarithmic equations. And in specific here, we're looking at what do you do when you don't know what type of equation you're going to be solving. So we looked at some where you're given and you use the definition of logs to solve by taking a logarithmic equation and rewriting it as an exponential. And we also looked at problems where you use the property equality for log functions where you get log base b of x is equal to log base b of y, set x and y equal, and then check for the domain restrictions. What happens when I don't really know what this is? So when we are trying to use the property of logs, it's really important that we get the log base b of y by itself. So in this case, this 2 here is a problem. So I have 2 times log base 3 of x plus 4 is equal to 54. I need to get rid of this 2 before I can proceed. So I am going to divide both sides by 2. And I get log base 3 of 27 is equal, log base 3 of x plus 4 is equal to 27. This is an insane problem that I'm just realizing, but that's okay. So I'm going to rewrite this as an exponential. 3 raised to the 27 is equal to x plus 4. I'm not even going to figure out let's figure out what 3 to the 27 is and then ignore it. 3 to the 27 is a huge number. It is 7.6 times 10 to the 12. So x is going to be equal to 3 to the 27 minus 4, which is approximately equal to 7.6 times 10 to the 12. So that was a crazy number, but you can see the process there. All right. Looking at our next problem, we can see that we have log base 5 of x plus 10 is equal to log base 6 of 1 plus log base 7 of 49. So what I'm seeing here is this doesn't really look like either case. The issue that I have here is I have log base 5, but then that doesn't look like a number to me. But I also don't have the property of equality because I, first of all, have 2 log expressions over here. And second, this is a 5, this is a 6, and this is a 7. So that's going to be an issue. But if I remember that a logarithmic equation, we're interested in the variable being inside. So the variable is inside here. So here I have a log with the variable inside. This does not have a variable and neither does this. That means log base 6 of 1 is equal to some number. So 6 to what number is equal to 1? That is 0. So I'm going to rewrite this. Log base 5 of x plus 10 is equal to 0 plus. Then I'm looking at log base 7 of 49 is equal to what number? So 7 to what number is equal to 49? And that is 2. So this becomes log base 5 of x plus 10 is equal to 2. And this now looks like this. I have a logarithmic expression that I'm going to use the property of logs. So 5 squared is equal to x plus 10. 5 squared is 25. So x is equal to 15. And if I check the domain restriction here, plugging 15 in gives me a positive number. And if I check the domain restriction here, plugging in 3 to the 27 minus 4 definitely gives me a positive number there. All right. Now here I have log base 9. Log base 9, so I'm going to go ahead and set these equal. So I have 2x minus 3 is equal to 6 minus x. And for my domain, I need to keep in mind that 2x minus 3 needs to be positive, and 6 minus x needs to be positive. And I'm going to use those to check. All right, so 3x is equal to 9, x is equal to 3. So let's go through and check. So I get 2 times 3 minus 3 is positive. That is true. That is 6 minus 3. And then here I get 6 minus 3 is positive. That also works. So that is my answer. So you just want to keep in mind that they won't always look simple, but our goal is to simplify things down to look like one of these two situations to solve.